So next experiment is actually you have to transmit hello world continuously using UART, universal asynchronous receiver and transmitter. I have to interface actually there is a LPC1768 has 4 built-in UARTs, that is a universal asynchronous receiver transmitters, that is UART0, UART1, UART2 and UART3. Okay, so similarly the pins are also named as RDX0 to RDX3 for receiving. For transmission, TX means transmission, D0 to TXD3. LPC1768 pins are multiplex for multifunctionals that we already discussed. So you have to search where actually that your pins are available using LPC1768 user manual. You have to search. Okay, some of the UART registers are RBR, THR, LCR. These are the important. We are going to use it in the program also. RBR register contains the recently received data. THR register contains the data to be transmitted. LCR actually controls the UART frame formatting. So using LCR, you can format how many data bits you are sending, how many stop bits, all those things you can control using LCR. So DLL and DLM they are used for baud rate generation. Okay, DLL and DLM they are used to generate some baud rate value. So if you change the values of DLL and DLM, baud rate value is also going to change. I will show that formula also. This FCR register is a FIFO first in first out control register. Okay, it LPC 1768 has inbuilt 16-bit FIFO for receiver and transmitter. One minute. Okay, this is you can read in detail the manual, different options. Actually, in the LCR register, we are putting the value of 83. In the first line of the code, we have 83. 8 means 100. Okay, 3 means 0011. So LCR is line control register. Why we have to put 83 only means 83 is last two bits are 11. Okay, so that actually indicates 8-bit character length data we are sending. We are transmitting hello world, no? So each character actually you have to put 8-bit character length. So it is 11 means 8-bit. If it is 5 bits, you have to put 00 here. If you put 80, that is 1000000, then 5-bit character length it will take. If you put 81, okay, then it will take 6-bit. If you put 10, that means 82. 100 means 80. 0010 means 80. This is 8, this is 2. 82 means 7-bit. Actually, in the program, we are putting 83. Here DLB is 1. Break controller is not used. Parity select is also 0. Parity enable is also not done. Stop bit select is also made as 0. So word length selection is actually 8-bit. That's why 11 is put here. And why actually stop bit? What is the meaning of stop bit select 0? What is the meaning of parity enable is 0? We'll see now. Second bit actually here. 0 times first bit is this. Second bit, if it is 1 means one stop bit is used. 0 means one stop bit used. If you write 1 also here, then actually two stop bits are used whenever you transmit any 8-bit character. After the data, two stop bits are going to send. Here it is 0, no? One stop bit is going to send. And third is actually parity bit is also made 0 here because we are putting LCR as 83. So this bit is also 0. So that 0 indicates that we are disabling the parity generation and checking. Okay, we are disabling the parity generation. If you made this as 1, the transmitting time it will check the parity, how many number of ones are there. Depending on that, if it is even parity, then it will generate extra parity bit either to indicate odd parity or even parity. So fifth parity, these two bits are parity select. Okay, these there is actually two bits are there. Those two bits are 0 means 0 means parity, odd parity. Number of ones is in the transmitted character and attached to the parity bit will be add. 0 means even parity. Number of ones transmitted character and attached to the parity bit will be even. 10 means one stick parity. 11 means forced stick parity. We are using 00. Here actually anyway we disabled this one. We disabled the parity generation. So the reset value is 00 only. So it will be 00 only. And brake controllers are not used. Anyway, this bit is also 0. So we disable the brake transmission. And last bit is 1. We use the DLB as 1 now. 83 we return. So 8th bit is actually 1, which is actually divisor latch access bit. So we had made 1, which indicates that we enabled access to divisor latch. Access to divisor latch. Okay, next we have one more register, line status register. Okay, here the bit 0 indicates that receive data ready. Receive data ready. If it is 0, actually the UART receiver first in first out output is actually empty. If it is 1, if this particular bit is 1, then UART receiver is not empty and some data is there. 0 means empty, 1 means some data is there, not empty. Okay. And other bits you can check, read slowly. And actually we are interested to see the fifth bit. Fifth bit is transmitter holding register. Okay, transmitter holding register empty, which indicates that if that particular bit is 0, transmitter holding register is empty. Empty means nothing to transmit. If it is 1, indicates that some valid data is there, you can transmit it. Okay, fifth bit we have to check, not all the bits. If fifth bit is 0, that means register is empty, nothing is there to transmit. If 1 means it has some valid data for transmit, you can transmit that serially. So other bits you can read. So this is the how it is going to transmit. We selected one stop bit. If you put 83 now, one start bit. This is the start bit is always 0. Start bit is 0 followed by 8 bits. So we selected 1 at the end, so it will select 8 bits. You select different option, you can select 5 bit, 5 data bits, 6 data bits, 7 data bits or 8 data bits. So we can, in the beginning we set the value as 83. So we are transmitting 8 bit and optional parity bit we made as 0. So it is not going to check parity, and we selected one stop bit. So how to transmit any data serially means you have to follow these steps. First configure GPIO pin, and you have to search where UART0 function is present. And by searching user manual, you will find UART0 function in some pin select register. Which pin selector we'll see that later. Okay, some pin select register will have UART0. You have to search it. After that, configure FCR register, enabling FIXO and reset both to RX/TX FIFO. Then configure LCR register. We are putting 83, no? That means it is we are configuring to 8-bit data, one stop bit, and disable the parity and enable DLAB. After that, this is optional. Next, you calculate DLM and DLL for required baud rate. You can set the baud rate as 9600 or 1 lakh 12,000 like that. So this is the DLM formula. Okay, baud rate formula. Baud rate is given by 256 into DLL plus DLM will give you P clock divided by 16 into baud rate. Okay, we have to assume one value and find out DLM. For example, if you want to have the baud rate of 9600, you write 9600, and in this expression assume any one value, either DLL or DLM you assume, and find out another value. Okay. So already we have a calculated value of that. So we can put that DLL DLM value. So if you search where that UART1, UART2, UART3 are present, so you have to search for TXD3. That is TXD3 and RXD3. TXD0 and RXD0 is it is for UART0. TXD1, RXD1 is for UART1. Okay. So we are interested only in UART0. So in the user manual, you search for TXD0. So you'll find out these pins, which is there in pin select 0. Pin select 0. Okay. There is a function TXD0, RXD0. This is the alternate function of port 0.2, port 0, pin 3, port 0, pin 2. So we want to use these two pins. So you're going to get TXD0. This pin will work as this when pin select 0, fourth and fifth pin are 0, 1. That means fourth pin should be 1, and again sixth pin also 1. Fourth and sixth pin should be 1. Please remember, in pin select 0, fourth and sixth pin should be 1, so that port 2.0 works as TXD0 pin. Port 0 third pin works as receive pin, and this will transmit pin. So in the program, fourth and sixth should be 1, pin select 0. So let us go to the program. So we are doing initialization of UART. We are doing initialization of UART. Void UART0 underscore capital INIT. So this is the function written in startup file, C file. So you have to use the same file name. Void UART0 underscore INT, or I think if it is, I think here only init file is there. Let us check. We are writing here UART0 init. UART0 capital UART0 underscore capital INIT function we are calling. So same function we are writing here, void UART0 underscore capital INIT. It's a case sensitive. So whatever name you written in the main program, same name you have to write here, void. And here you're doing pin configuration, LPC underscore pin configuration dash greater than mark. So in pin select 0, fourth bit and sixth bit are made 1, and do pipe operation. This is actually OR operation, logical OR operation. And this is OR operation means previous values will be ORed with the new value. So here also you can write pipe operation to add the previous values, or you can simply write is equal to also. Okay. This you can omit. This pipe you can omit. You can directly write is equal to, or if you write this vertical line also, it's okay. So this you can get it vertical line. You can get it by typing shift slash button. Shift backslash above enter button. Above enter button, there is a slash. If you click shift and that, you'll get this vertical pipe. After that, whatever register we discussed, no, those values you have to configure. initialize the UART. LPC underscore UART0 dash greater than LCR is loaded with 83. You can see the comment. We are configuring as 8-bit and no polarity and no parity. This one is not polarity, it's no parity. One stop bit and DLL and DLM. One value we assumed this as 0 and calculate a DLM for 1,15,000 and clock rate we have selected as 25 megahertz. For that one value if you assume and check we'll get DLL as 9 approximately. So set the value of DLM as 0, DLL as 9. You are going to get 1,15,200 as the baud rate. So this is actually baud rate, BAUD. Okay, typing mistake is there, two type. This is parity, this is baud rate. LPC underscore UART0 LCR value is put for 3. This will actually, once you set the baud rate, we have to lock it. By writing 1 it will lock. After that, using FTR register, we are actually putting the 21 value for this FTR. You read in the user manual just above there what is the meaning of this TDR and all. Okay. So these 4 lines you have to know. LCR is 83, DLM 0, DLL 9, LCR again 03. Okay. 03 for locking. First you have to set the baud rate. After that you have to lock it. Then FTR is loaded with 21. Next, in the main program, what is there? First, you have to initialize system init. I think this is capital system init. S is capital, I is capital. Because all these functions are written in startup file of LPC1768 header file. So, you have to use same line. Sometimes even if you remove this system init, it will work. Okay, this is optional line I think. System init you have to do. Then UART init, it will do the first these lines, and while one continuously it will transmit hello world in the terminal. If you connect any serial window, it will show that. Otherwise, if you want to see the simulation, there is a terminal application. It is there in the Flash Magic. So there only you can open the terminal and you can observe hello world is coming. Okay. So while one means for continuous transmission, infinitely it will work. It is the super loop based approach. So UART0 send string capital S capital S. It is a case sensitive because same name is used here also. If you use different name here, same name you have to write here. Capital S here also capital S. If you write in small letter here also you have to write small. So what is there here? Here we are declaring unsigned char S, star S is the pointer, and while the content of pointer star S is uh, not equal to 0, that means it is not an end of string, then you have to transmit. Okay, if it is equal to 0, then you have to stop. Okay, if it is not equal to 0, you have to send. What you have to send? First you have to send character. Okay, initial value of S is 0. It is going to send the first value H. In the string it will send first letter H, and after that it will increment by 1. In the next time, because it is a continuous now while 1, so next it will send next value E, next L, next O world. Okay, last once it comes it will stop here. And even if this full thing is written, once you send UART with argument as hello world, that argument is taken here and it will print this full. Okay, after the completion of this, once again this is everything is written in while one only. Once again it will call the same function, again the same argument is sent here, calling function with argument. So again it will take a pointer s with this string. It will send HELLO world. Lastly we will get 0, so that it will stop sending. Again it will come back here. So this will execute continuously because it is written in while one. So you can see the demonstration video is also there in the uploaded in the Google Classroom. You can see the output of how to check the output of UART0, how to send transmit hello world continuously with the help of UART0. You can check that also.